Hello, my name is Espik, and welcome to another KTaNE module tutorial. And this time we're looking at superposition. Superposition is a very long module, very lengthy, but I think it's pretty kind of interesting. So this is what it looks like. It makes a little sound at the start. It has a 5x5 grid of cells. That's what each of these panels are called. They're called cells. And highlighting over each of them will give you a bit of information on the top and right displays. Now, the first thing that you should know is that you actually only need to look at one of these displays. The other one can be completely tossed out. And the first thing we're going to do is find out which display that is. But before we start, just to note that this module is heavily solve dependent as well as strike dependent. So if you're giving this out, always specify like how many solves or hopefully not regarding strikes. Usually just say how many solves you're going to do superposition for. Now, the first thing, like I said, we're going to find out which of these displays we don't need, and we're going to find out using these right here. So, the waveforms. Well, module calls this the collapsed superposition. The collapsed superposition is going to be the relevant one. And each of these, the waveform in this case, is all the information given on the display. So we're going to go through each of these rules in order, and the first one that applies. If one of the waveforms is missing a cell, let's take a look. So let's highlight and see if any of these is completely blank. Nope, they're all displaying some information. If there are multiple superposition modules, well, this is a one module bomb, so in this case, no. If both displays show cell 12 are the same color, I should have mentioned this earlier. The way that the module labels these cells are from 0 to 24 in reading order. So this is 0, 1, 2, 3, 4, 4, 9, 14, 19, and 24. 12 is right in the middle. So both, in this case, the top color is orange and the right color is yellow. This is not the case, so this rule does not apply. But I will go over these quickly. So it'll ask about the waveform of the highest number. So in this case, if this did apply, it would compare the two numbers. The top number is 3 and the right number is 6. So the highest number is the one we'd use in this. And if they tie, this rule just doesn't apply at all. If the bomb at least one DVI port, TS2, and RJ, which means all three of these ports has to be present. That is not true. We do not have a DVI port. But the sum of the digits, sum of the numbers in the first column in exactly one of the waveforms is greater than 20. You use that one. So the first column means this. So we're going to find all the numbers on the top display and on the right display and sum them up. So, and one of them, exactly one of them has to be greater than 20, not neither and not both. So it's like an XOR operation. So we have 5, I'll just write them down for you. 5, 7, 3, 3, and 6. And that's for the top, and for the right we have 1, 4, 8, 8, 0. Okay, let's add them up. So 5 plus 7 plus 3 plus 3 plus 6 is 24, which is greater than 20. 1 plus 4 plus 8 plus 8 plus 0 is 21, which is also greater than 20. In this case, since they're both greater than 20, this does not apply. The bomb is more lit than unlit indicators. We have no indicator, so that's not true. If exactly one waveform have different colors on each of its corners, basically means that all 4 corners have a different color in exactly one of them. So let's take a look. For the top display we have blue. Oh yeah, this status light. This is how you'll be submitting the module, but we'll get into this later. Orange, blue, and red. So this does not apply for the top display since we have 2 blues here. And let's look at the right display. We have blue, green, purple, and yellow. This does apply, so exactly one of them. So we're going to be using the right display for the rest of the module. let's go over the rest of the rules just to make sure that you guys understand them. 3 and 2, that's easy enough. Cell wave 1, blah, blah, blah. Exactly one waveform cell 24, which is the bottom right, shares a letter or a number with the bottom serial number, then use the other one. Serial number has no vowels, and the top display. So yeah. Something to mention is you can actually toggle each of these cells in the grid right here. They don't. You can do it whatever you want with them. You'll still be able to see all the information on both displays. But for now, let's untoggle them. And to submit, you'll be using this data slide. So we got this rule, and exactly one waveform. So we determined that the right display here is the collapsed superposition. So the collapsed is the right, which means that we can completely ignore the top display. Now you don't need all of this information right away, but I recommend writing it down. We're going to get essentially what each of these cells highlights in the right column, and I'm going to go in reading order here. So the way that I like to write it down, and the way that you probably should, is you write down the letter that's displayed here. Hard to do it when it goes away. Then the number, and then the color, abbreviated as one letter. Then the colors the module uses are red, orange, yellow, green, blue, violet, and white. And each of those colors has a different first letter to its name. So they should be distinguishable enough. So the first cell here would be Echo 1 blue. So we're going to write Echo 1 Bravo for blue. Then Sierra 1 violet. Juliet 6 yellow. November 8 green, Lima 0 green, and it will always be letter than number for these displays, by the way. Tango 4 white, just gonna double check. Yep, okay. Oscar 4 violet, Charlie 8 green, that's Delta, so Delta 8 blue. Okay, the whiskey and Mike on this font is kind of awkward. This is Whiskey 4 orange. Zulu 8 orange, although that looks more brown to me, but regardless, it's orange. Victor 1 violet. Yellow 6 yellow, or yellow, Yankee 6 yellow, excuse me. Mike, yeah, that's a weird looking Mike. It really does look like a whiskey upside down. But anyway, Mike 5 blue. Uniform 5 yellow. X-ray 8 green. Golf 0 white. Romeo 0 white. Bravo 8 blue. Kilo 6 violet. Alpha 0 yellow. Hotel 3 blue. Foxtrot 9 red. Quebec 4 blue. And finally, Papa 3 violet. So that's all we need from the module. I'm still going to go back to the module to highlight it, just to make stuff a little bit easier than rather than just looking at notes. I'll get rid of this as well since we don't need it. Okay, so the way that this module works is there's 4 different rule subsets, or steps in this case. And each of those steps will give us 6 of these cells that are valid according to their rules. And the same cell may be valid in multiple rules. What we want to find out is how many cells are valid by only one rule. And we find out which cells those are, press them down, and then submit. So in theory, we could press no cells at all, or all of the cells except one. So we're going to go through each of these subsets, starting with step 1, the letter ciphers. First, I need a cipher code. So this is originally the SPOM serial number, So it's right here. We're going to write it down 4, delta 4, delta echo 8. Now, I'm going to split these up like this, just so they're easier to read and permutate, or not permutate, I guess alter, regardless. So the first thing that this thing specifies is there's a missing letter. Now, if you've been paying attention, you know that nearly every single one of the 26 letters has appeared in one of the displays, with the exception of one. So we're going to find what that letter is. And we're going to start in the alphabet and then look for the first letter that we can't find. So started alpha, we have alpha, it's right here. Then Bravo, Charlie, then Delta, Echo, Foxtrot, Golf, Hotel. Do we have India? I don't think we do. Let me check using the find function on Notepad. We do not have India. So India is our missing letter. In this case, this sequence doesn't have an India, so we don't need to worry about that. But if it did, I'm gonna quickly run you through the missing letter conversion. So let's say if we had an India in the serial number, because India was our missing letter. So we need to take the last digit of the serial number, which is 8, add 1 to it. Then apply a Caesar cipher of the missing letter forwards by whatever the number we got. So in this case, India is 9, and add 9 to that because it's 18, and 18 is Romeo. How do I know this? It's going to be outside the scope of this tutorial, but it's done through a lot of practice and memorization. So on this, we're actually looking at this again. We actually don't need to know that. So we need to find cell number 18 in the waveform. Wait, is this correct? Oh, no. Okay. So I was right. So we need to find in the waveform. The waveform is essentially in this grid which cell has Romeo for its letter. Do I see it? I'm not seeing it. It's here. Okay. So this cell right here, I'm going to just press it to make it easier for you to see, is the cell that we've got from this. Now, we're going to use the first two characters of the serial number. In this case, it is a number followed by a letter. In this case, it's hash then X, where X is a letter and hash is a number. So we move right of that cell we just found to this cell. So if we had any Indias in the serial number, we replace them with whatever letter we had here. In this case, Bravo. But because we did not, we don't have to do that. Okay. So now I know it's a little sloppy, but I thought I'd let you just go through that. Now we still have numbers, and we want to get rid of all our numbers. So the way that we do this is we take each number. If it's 0, you change it to 10. Multiply the digit by its position. So, okay, so the first position is a 4. 4 times 1 is still 4. We have a 4 in the third position. 4 times 3 is 12. And we have 8 in the sixth position, and 6 times 8 is 48. Double the number into its 2 digits long. So these two numbers right here are already 2 digits, so we don't need to touch them. So, but this number 4 here is still just a single digit, so we double it, and it becomes 8, which is still a single digit, so we double it again, and now we get 16. So then we add the digital root of the number to itself. The digital root is the sum of each individual digit, so 1 plus 6 would be 7. That's a digital root of 16. So we add 7 to 16 to get to 23. 1 plus 2 is 3, and 12 plus 3 is 5. Or, excuse me, 15. I can't do math. No one heard that. Then 4 plus 8 is 12. The digital root of that is 1 plus 2. So, as you mentioned, digital root, just keep going until you have a single digit. So in this case, the digital root is 3. So 48 plus 3 is 51. Okay, just want to make sure I did this correctly. Okay. Next, then modulo the result by 26, just to give us a valid letter in the alphabet. So in this case, the only number that's bigger than 26 is 51. So that would give us 25. Then we turn it into a letter based on alpha 0 Zulu 25. So in this case, or you can just add 1 to all of these and turn it into a letter, which is what I'll do here for simplicity. The 24th letter is X-ray, the 16th letter is Papa, and the 26th letter is Zulu. Sorry for the noise. If the resulting letter is not in the waveform, essentially, if any of these letters is one of the missing letters in here in the waveform, then Caesar shifted forward by 1 to the next letter. You are allowed to have duplicate letters at this point, but there will be some steps where you cannot. So I'll keep that in mind, and you should as well. In this case, we don't have any Indias, so we're fine as this is. Now what we're going to do is use a Playfair cipher. So if you're familiar with models like Playfair cipher or unfair cipher, this should be easier. So our grid for the Playfair cipher is simply the grid we got in the waveform. So I'm going to copy all of this and only have the letter part. So we're going to do this. It's going to take a little bit. Wait. I messed up, didn't I? Okay, there we go. So, the way that a Playfair cipher works is, I'm not going to go into too much detail into it. If you want to know in greater detail, look at the tutorial for Playfair or unfair cipher. So we're going to have each of the 6 letters and put them into pairs of 2, like this. Oh, we do have duplicate letters. I thought I didn't. Okay. And we find their positions in this 5x5 grid. So now, if you're familiar with Playfair cipher, unfair cipher, we're actually encoding, not decoding. And the manual says this right here. So if they're in the same column, you go down, and if you're in the same row, you go right. Where if you're decoding in a Playfair cipher, if they're in the same column, you go up, and in the same row, you go left. And but that's not the case here. And if you get the same letter twice, then it just doesn't change. So we're going to find X-ray, which is here, and delta, which is here. And the letter in the same row as X-ray that's in the same column as delta is Bravo. And the same row as delta, the same column as X-ray is Tango. Always go row, then column. Again, sorry for the noise. For Papa and Delta, we find Papa and Delta, they're here. So the same row is Quebec, and then same row here is Whiskey. For Echo and Zulu, we do have them. They are in the same column, so in this case we go down from their position. So down 1 from Echo is Tango, and down 1 from Zulu is X-ray. So that's the Playfair cipher done. And I'm just going to get rid of this. Okay. Next we need a Caesar cipher. So we take the sum of the digits in the bomb serial number. 4 plus 4 plus 8 is 16. So And if the last digit of the serial number is even, we go forward this, so we add 16 to each position. Otherwise, we subtract 16. Also keep in mind, it doesn't say right here, but keep your answer for what you get after this step, because you might need it for the next one. So in this case, 16, Bravo is 2, we add 16, we get 18, that's Romeo. Tango is 20, 20 plus 2, 16, excuse me, is 36, that's bigger than 26. Subtract 26 to get 10, that's Juliet. Then we have Quebec, which is 17, plus 16 is 33. Subtract 26 is 7, which is Golf. I don't know what my caps lock is doing. Whiskey is 23. And that leads us to 13, which is Mike. Tango is 20, it's going to lead us to Juliet, we've already found that earlier. And then 24, X-ray is 24, minus that is 14, which is November. Okay. Now we do an at-bash cipher. An at-bash cipher, there's only one way to do this. So, what we do is we take the alphabetic position and subtract that from 27. So 27 minus 18 for Romeo is 9, so that becomes India. 27 minus 10 is 17, which is Quebec. 27 minus 7 is Tango, which is 20. 27 minus 13 is 14, which is November. 27 minus 10 for Juliet is 17, which is Quebec. And 14 is 13, which becomes Mike. So interesting. So this is the one step we cannot have duplicate letters. And additionally, we have an India here. And as we found out earlier, India is the missing letter from this waveform. So we can't have that. So when it says, if any of these letters do not appear, revert to letters back to where they were after step 2, which is this, or cipher 2, excuse me. So in this case, this thing doesn't change, and we keep it as Romeo. Or you can just do an at-bash cipher again to get it in case you deleted your notes. And now we have duplicate letters. We have 2 Quebecs here. So for each duplicate letter, Caesar shift that letter forward until it is no longer a duplicate letter. So in this case, we always do the first one. The first one is this Quebec here. Add 1 to get Romeo. Now Romeo is also right here. So in this case, we do one more and get Sierra. Now, actually, now we're looking at this, the order doesn't matter here. About which one I did. It didn't matter because we're going to get 6 cells anyway, and it would have gotten the same result. And the 6 cells, it doesn't matter the order. For any of these subsets or steps, the order of which we get the cells does not matter. So we're going to take the cells that have these letters, and those are going to be our first valid 6 cells. So we need to find the cell that has Romeo for its letter. That is this one right here. I'm going to mark it as Delta. That's Charlie 4. And Sierra is this one, so Bravo 1. Tango is this one, and I'll prove it like Sierra. As you can see, Sierra and Tango and Romeo. This is Alpha 2. Then November, which is this one, so Delta 1. Quebec, which is this one down here, so Delta 5. And Quebec, oh no, I already did Quebec. Mike is up here, Delta 3. So these are the first 6 cells we got for step 1. So I'm going to write them here. Okay, that's step 1 done. Now time for step 2 to get another set of 6. And don't worry, step 1 is one of the longer steps in this module. You don't have to do something that long for the rest of this. So down here we have number math. The first we need to find is our starting number. So we need to take the sum of the first row of numbers. In this case, the first row is this top row right here. So we need to find the sum of all these numbers. And I have them written down right here. So we have 1 plus 1 plus 6 plus 8 plus 0. In this case, it's 16. And we subtract the last digit of the serial number. The last digit is 8, which gives us 8. Then multiply this value by the value in the cell that is corresponding to the number of batteries in the bond. We have 1, 2, 3, 4 batteries, so the cell 1, 2, 3, 4. The number here is 0 for this one right here. So we multiply it by 0 and we get 0. Take the absolute value. So you are able to get negatives, since assume like if they were all ones and like the last digit was like 9 or something. But add the number of solved modules. In this case, we don't have any solved modules. And this is really the solve dependent part of the module right here. If modules are solved by 25, in this case I don't do anything, and this is the starting number. In this case it is 0, which is the top left here. Okay. Now, the way that the manual words this, I don't like. I find it confusing, and I wasn't able to figure it out from the manual here alone. So I'm just going to tell you what you have to do here. Sorry for clicking this by accident. So what it wants us to do essentially is we take the cell value of whatever this is and add the number from that cell. So in this case, in cell 0, the number is 1. Add that to the 0, and that's the next valid cell. So in this case, it's 1. Then add 1 on 1 to get 2. And cell 2, which is this one, the number is 6. So we add 6 to 2, and we get 8, which is this one over here. The number here is 8. So 8 plus 8 is 16, which is this one. And then the number here is 0. So in this case, we get the same cell as before. If it's already made valid, makes the next non-valid in the step without changing the cell number. So in this case, if I were to get this like earlier, or there was another one, this is actually not the best example since it's 0. But if this were like 2 for something and the cell was already taken, I would go to the next one, but I would still use the value of whatever was in here. In this case was 8. So in this case, because it's 0, we don't move, and we just take the next one, which is 17. And I like to put these in terms of actual grid notation like this. This we have alpha 1, Bravo 1, Charlie 1, Delta 2, Bravo 4, and Charlie 4. So those are the valid cells for the second subset here. Next is our color sequence for step 3. So what we need to do is find the color of cell 0, the top left corner. In this case it's blue, and blue is going to be the column. So we highlight this column that has blue in it and find the last cell. In this case the color is violet on the display on the right here, so we use that as the row. So we get a color sequence. In this case it's yellow, green, orange, red, white, violet, blue. Now we need to go in reading order, and we need to find all valid cells in reading order that start with the first color of the sequence. So I'm going to actually copy this into my notes like that. So the first color here is yellow right here. What we need to do is find all yellow cells in reading order. So let's just go for them, find them. In this case, we found one right here is Charlie 1. We keep going on till we get yellow. I'm using this just to make it easier for me and also easier for you. So Charlie 3 is also yellow. Let's mark that. And Echo 3 is also yellow. And we keep doing this until we have 6. Okay, Alpha 5 is also yellow. And that's all the yellows. So now that we've gone through the whole grid, we take this color off right here, and now green is the first color. So now we need to do the same thing, except look for green cells. Here's the first one here. It's Delta 1, and then Echo 1. Now we have 6, so we stop. And that would be the valid colors for the third step, or valid cells, excuse me. Finally, the cell matching. So we have this table right here, and we need to use it to find the true. We need to find exactly which statements are true and how many of them are true for each column. And the column with the most true conditions will be the column that we'll use, and I'll get to that after this. The middle cell right here is already given for you. This muzzle is attached to an explosive device. This one is always true. But we're going to go through all of them. So, first condition, the last digit of the bomb serial number is less than the number of batteries in the bomb. Our last digit is 8, and we have 4 batteries. This is not true, so I'm going to mark it in red for not true, and I'll mark it in green if it is true. No white cell has the letter Alpha or Zulu. The way that I'll find this is through Notepad's search function. So I'm going to look for W in my notes and find, so anytime W is in the third position, that means the color. So we're going to find if the first letter is Alpha or Zulu. In this case, it's not. So this rule is true because no white cell has the letter Alpha or Zulu. The bomb is an even number of battery holders. We have 3 battery holders, so that's not true. Any green cell in the waveform shares a character with the bomb serial number. Again, we're going to consult here. So in this case, we have 4 green cells, and they have the letters of Lima, November, Charlie, and X-ray. Our letters in the serial number are Delta and Echo, and none of these letters are in common at all. In fact, Delta is here, which is blue, and then Echo is here, which is also blue. So this rule is false. The bomb has no strikes. In this case, it's true. We do not have any strikes right now. The bomb was started on a weekend. In this case, for me, it's Thursday, so no. The bomb is missing batteries, indicators, or port plates. Essentially, are there no batteries, are there no indicators, or are there no port plates? Either one can be true. In this case, we don't have any indicators, so this is true. At least 6 cells in the waveform have the same color. Let's clear the marks again. So there are 7 colors. We're going to see. You can count them, but I'm going to use the mark function. I've been saying it's the search function, but I'm also using the mark function in Notepad++. So we're going to find how many red cells we have. In this case, we only have 1 right here. We're going to keep doing this for all 6 colors. Orange, we have 2. Yellow, we have 4. And we're going to keep doing this until we find one with 6. Green, we have 4. Okay. Blue, we have, I think that's 1, 2, 3, 4, 5, 6. Aha! So this one, we do have 6 blue cells, and I'll show that right here on the right side. So this rule is true. The last digit of the ones digit of the number of ports in the bomb is present in the serial number. So basically what this means, take the number of ports modulo 10, and is that digit present in the serial number? In this case, we have 4 ports, and we do have a 4 in the serial number, so this rule is true. The serial number contains at least 1 letter from cells 0 and 24. So in this case, cell 1 is Echo, which it is, and then cell 24 is Papa, which it's not, but this rule is true. Now at this point I would stop here, since 4 rows in the same column are true, but it is possible for 5, but I would be pretty confident at this point that I had enough, but I'm going to keep going for the sake of explaining every rule for this tutorial, and just in case I am wrong, and there is 1 column that has 5 rules. In this case, if I really wanted to be sure, I could just check for any false condition on, for like, if I check these 3, for example, to see if they're true or false, and if they're all false, then I know that there's no rule of 5. In this case, actually, there also could be a tie, and ties actually go to the right. So in this case, this one also had 4, then I would use this column instead. But if you feel, it's basically saying that if you're confident enough, you can stop here. But I won't. Anyway, there are no vowels in the first word of the waveform. So let's check with Echo, Sierra, Juliet, November, and Lima. We do have a vowel in Echo, so that's not true. The bomb has an indicator which shares any of its letters in the bomb serial number, but we don't have any indicator, so that's not true. at least one red cell in the waveform has the number 1. So let's take a look. We're going to find red. In this case, there's only one red cell here, and it has the number 9, so that's not true. The sum of the bomb's serial number digits is less than 2 times the number of batteries in the bomb plus the number of lit indicators. So the sum of the bomb's serial number digits, which we've already found out to be 16, is is less than 2 times the number of batteries in the bomb plus the indicators. We have 4 batteries plus 0 times 2, and we get 8. 16 is greater than 8, so this rule is not true. The bomb serial number contains any character in Quebec, Uniform, Alpha, November, 7, Mike, or Quantum. There is a 4, so this is true. The right display is the collapse superposition. Basically, are we looking at the right display for this module? We are, so that's true. No parallel port on the bomb serves to play with a serial port. This rule is kind of weird, essentially, but essentially this rule is false if there is a parallel and serial port on the same plate. If we have no parallel ports, then this rule is true. In this case, we don't have any, so yeah. And if we did have any parallel ports, this rule would still be true as long as that same port plate that had the parallel port did not have a serial port. At least one cell with the number 0 also has the letter Zulu. Okay? We're going to look for 0. In this case, we have Lima, Romeo, Golf, and Alpha, so that's not true. The bomb does not have any D batteries. That's not true because we have 2 of them right here. The number of warm colors in the waveform, which includes red, orange, yellow, and white, is greater than the number of cold colors, green, blue, and violet. So we're going to count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then that's it. For there to be a majority, there needs to be 13 or more. So in this case, we have 10, which is less than 13, so that rule is not true. Lit bob indicator, again, no indicators. That's false. The waveform is missing any number or color. We already checked earlier for colors. We stopped at blue, so we're going to keep going with violet to see if we have any violets. I'm pretty sure there are, and yet we do. Okay. We're also going to check white, and we do have white. We have 3 of them. So now we need to check numbers from 0 to 9. Let's start with 0. We do have 4 cells with 0. 1. We have 3 with 1. Ignore anything that gets marked down here. Then we have 2. Actually, we do not have any cells with 2. And you can even take a look at the display here. We have not seen any cell with 2. So this rule is true. The bomb does not have any unlit indicators. This is also true. And the waveform's missing letter is a vowel. It's India, which is a vowel, so that's true. So we're done with that, and we could have stopped earlier if we wanted to, but we didn't. So the sum of the true rules in the column, we have 2, 4, 1, 3, 3. The most goes to this second column right here. So this is the column we're going to be using in this table, which also has 5 columns. So we're going to highlight the second column right here. We're going to be using this first. Then, and this is why I suggested to notate the waveform like this, is because it's going to be relevant for this table right here. Essentially, each of these cells in the table right here refer to a permutation, or I guess some combination of data written like this. And there can be some information missing. If the letter is missing, then it's substituted for a dash, number is substituted for the hash sign, and a color is substituted for an exclamation mark. I don't know why they made it differently for every form, but regardless, it essentially means it could be any letter, any number, or any color. So we need to find, and it gives an example, a red cell labeled alpha 1 would have alpha, or would meet the condition for alpha 1 red. So we need to find the cell, excuse me, that has this conditions met. So the first one here, the first condition, we're going to start in the table and go downwards. We're going to start with this cell right here, Papa 0 exclamation point, which basically means, is there any cell that has Papa and 0 regardless of the color? I'll use yellow. Okay. Again, we're going to go back to our search function. We're going to search Papa 0. We don't have any in this case, so we're going to ignore this. Then we need to find any cell that has the label X-ray and the color violet. So let's find that. I'm going to simply search for X here. We find the X, it's in green, so that's not true. Now this cell right here, R0Y, is a specific permutation. So it's unlikely we'll get it, and do we? Nope, we don't. Next we have kilo in green. So take another look at this, and you're going to be doing this a lot. It's a little tedious, I know, but that's the way the module is. So we're going to find kilo, it's in violet, so that's not true. Then we need just the number 6 in general. Wait, what did I just do? I know what I did. Sorry, I just got stuff disarranged with my windows. Anyway, 6. So let's clear the marks. So in this case, we do have some valid cells at long last. So in this case, if we have multiple ones, use the first non-valid cell in reading order. So additionally, if a cell lands on a cell that has already been used, you just skip it. In this case, so even if only one cell has the true conditions, if it's already been used, then skip over the row. In this case, Charlie 1 is the first cell that meets this condition right here. So let's use it. Next is orange, or Oscar 0 orange. Do we have any of that? We don't. So next is 1 green, and the letter can be whatever. So let's find that. We do not have that either. I'm not able to display the separate window in Notepad++ to for the search and mark function. So that's why if you're like, how do I know if I can't find it? It's because it's in a separate window that I unfortunately can't record. Then just the color blue is the next condition. So the first cell is this one right here, the first one, alpha 1. Next we have Zulu 9 in any color. Do we have that? No. Okay. Then 5 in red, any letter. Do we have that? Nope. So now we're done with this column. So what do we do now? We go to the next column to the right. And if you were on the rightmost column, you would then move over to the leftmost column. So we keep going until we have 6. In the case if you run out, then you just go in reading order, essentially. That's what this rule is. If you use every column excluding out of 6, validate cells in the waveform starting with 0, which are not already valid. So essentially, you would go in this order. Let's look for blue 0 white. Nope. Let's make sure I'm displaying the right window here. I am. Then 6 in yellow. Yep. Now Charlie 1's already been used, as we have right here. So we go to Charlie 3. Then we just have green with any color and any digit, or any letter and any color. In this case, the first one that applies is this one right here at delta 1. Then 3, which means that any cell that just has 3, that's not, I meant to, I typed in echo by accident. So the first one that applies is all the way down here at Bravo 5. That's true. Mark that in green. You don't need to mark it and whatever, just make sure you know exactly which rules you've already done. Next, we have uniform to Victor, or uniform to Violet. Hard to keep track of exactly what each of these means. So we don't have that. Next, we need 9 in orange. Nope, don't have that. Charlie 7, any color. Nope. Then we did have magenta in green. I'm just going to look for magenta. Mike in green. Excuse me. I'm getting my stuff mixed up. As you can see, Mike is in blue, so that's not valid. Then whiskey in white. In this case, the whiskey we have here is in orange, so that's not true. Then we have Echo 4. That's not true. We're done with this column. Let's go to the next one. 8 blue. Do we have 8 blue? Yes, we do. We have 2 cells that have 8 and blue, which are delta 2 and delta 4. Both of them are unused, and the first one that comes in read order is delta 2. So we use delta 2. Now we have 6. We stop. And those are the 6 valid cells for the rule 4. Now we have all the valid cells that we need. So the final part of this module, we need to find out which of these valid cells are only used in one rule. The way I'm going to do that is I'm just going to list out A, B, C, D, and E right here, and mark it out with numbers for which cells are valid. So Charlie 4, Bravo 1, Alpha 2, Delta 1, Delta 5, and Delta 3. The second row, Alpha 1, Bravo 1. Now Bravo 1 is already used, so I'm going to mark it with an asterisk, indicating that it's already used, and therefore it will not be part of our solution. And Charlie 1, Delta 2, Bravo 4, and Charlie 4, which has already been used. Then we have Charlie 1, that's already been used. Charlie 3, Echo 3, Alpha 5, that's 6, Delta 1, that's already been used, and Echo 1. And for the last row, we have Charlie 1, already been used, Alpha 1, that's already been used, Charlie 3, that's already been used, Delta 1, that's already been used, Bravo 5, and Delta 2, that's already been used. I'm gonna quickly remove all the cells that have been used from here. And now at long last, we have our solution. Our solution, we're gonna toggle Alpha 2, Alpha 5, Bravo 4, Bravo 5, Delta 3, Delta 5, Echo 1, and Echo 3. And to submit, we press the status light. And that is a solved module. As you can see, that took me 48 minutes. Now, hopefully it won't take you that long, but like I said, this module is very, very lengthy, and although the rules aren't that hard, you're probably going to take a long time on bottom. So if you see this module, I would recommend doing it early. And again, specify a solve count, since that will also be relevant. But that's all I'll be doing for this tutorial. I hope you found it useful. I'm not as professional as my other ones, but in all honesty, this module's hard and there's a lot I need to explain, so I'm bound to make some mistakes. I'm actually kind of surprised I got that, since actually it's only my second time doing the module. But anyway, that's going to be it for me. Thank you all for watching this tutorial, and as always, keep talking and don't explode.